Lecture 3. Models of Cognitive Development. The relationship between new and old belief systems in child development. In this lecture, I will tell you what happens to our beliefs as we ascend up the ladder of knowledge. I will consider 3 models of how the competition between the old and the new knowledge can be resolved, and report the experiments that tested these models. This is the main publication to this lecture. Cognitive development involves competing relationships between the old, early, and the new belief systems about the world. For example, Piaget stated that when children go to school, their early intuitive beliefs about biology, physics, psychology are challenged by scientific knowledge. For instance, preschool children believe that clouds are alive, but at school they are told that clouds are nothing but steam in the sky. The problem for the discussion, therefore, is how do old and new types of beliefs resolve their competition for power over the mind of a child? There could be various answers to this question, and we are going to consider 3 of them. Model 1, disappearance replacement, states that the old beliefs disappear from the mind and are replaced, substituted by the new beliefs. Model 2, inclusion modification, states that the old beliefs are incorporated into the new beliefs. A mixture of new and old beliefs is created. Finally, Model 3, conservation coexistence, states that the old beliefs do not disappear from the mind. Instead, they are conserved and remain on the bottom of the mind, coexisting with the newly acquired beliefs.
The 2 most prominent developmental psychologists of the 20th century, Swiss psychologist Piaget and Russian psychologist Vygotsky, held different views on the relationships between the old and the new knowledge in cognitive development.
Piaget tended to Model 1. He portrayed cognitive development as a replacement of the old, naive theories and beliefs by scientific theories and beliefs. In contrast, Vygotsky was more in favor of Model 2. In his view, lower mental functions are being transformed into higher mental functions and become incorporated in them. However, there is a problem with both Piaget's and Vygotsky's view on cognitive development. Both Piaget and Vygotsky studied beliefs as they are presented in children's verbal judgments. But would the replacement model and the inclusion model work equally well if the beliefs are recorded via children's actions and behavior? In the experiments presented in this lecture, we are going to consider the validity of the 3 models, using the relationship between phenomenalistic perception and rational understanding in the mind of an individual. Rational understanding of objects and events is looking at the objects and events through the prism of scientific theories, measurements, and interpretation of experience. This is what earlier in this lecture I used to call the new knowledge. Phenomenalistic perception of the same objects and events is looking at the objects and events directly. It is not mediated by scientific methods and theories. Phenomenalistic perception is what earlier in this lecture I used to call the old knowledge. For example, phenomenalistically we perceive sunset and sunrise as if the sun orbits around the earth. Rationally, we know that these events are the result of the earth spinning around its axis. Example 2. Phenomenalistically, we feel that a hot object contains heat inside itself. But rationally, we know that what the object contains is not heat, but molecules in motion. Heat is a subjective feeling, a result of the processes in our brain.
In one of his famous experiments, Piaget showed that preschool children's view on things is phenomenalistic. But in school children, this wrong view on things changes for the right one, based on rational understanding and scientific knowledge.
For example, 4-year-olds believe that pouring the water from the left container into the right one changes the amount of liquid. In contrast, 8-year-olds think that the amount of liquid remains the same. So, the aim of the study was to check whether the phenomenalistic view disappears from the children's behavior as soon as they discover the truth about things, or whether this wrong view becomes hidden but still remains in the child's mind. If the phenomenalistic view remains hidden in the mind, this view would show itself in children's actions when the children need to solve a practical task. However, if the phenomenalistic view disappears from the mind, the children will solve the practical task on the basis of their rational understanding of things. In order to approach the issue empirically, we need first to create in children two conflicting views of the same events, one phenomenalistic and the other rational-based. And then to see which of these views would prevail if children had to use them for achieving some practical goals.
In experiment 1, 4, 5, and 6-year-old children were presented with two rows of identical pieces of chocolate. Both rows contained the same number of pieces, but one row was twice as long as the other.
The children were asked, do the rows have the same numbers of chocolates, or does one row contain more chocolates and the other one less? Which row contains more chocolates?
By asking these questions, we tested whether the children have the phenomenalistic view of the numbers in the rows, saying that there are more chocolates in the long row.
After that, the children were asked to count the chocolates in both rows and see that there were equal numbers in both rows. By this, two contrasting views of the display were created in the child's mind. The phenomenalistic one, more chocolates in the long row, and the rational one, both rows contain the same number of chocolates. After a destructive conversation, the children were promised that chocolates from one of the rows would be given to them as a New Year present. They were then asked to pick up the row they wanted to be their present. We expected that if children relied on their phenomenalistic perception, more chocolates in the longer row, then most of them would pick up the longer row. If, however, they were guided by their rational knowledge, both rows have the same number, then they would pick up any of the rows at a chance level. After the children picked up the row, they were asked again whether there were equal numbers in both rows, or one of the rows had more. This was done in order to find out whether the rational view acquired through counting took over the phenomenalistic responses in children's verbal judgments.
As on this graph, you can see that more than 80% of children answered that there were more chocolates in the long row, but only about 50% picked up the long row in a practical situation. When asked for the second time, up to 90% of children correctly said that there were equal numbers in both rows.
We can therefore conclude that in the practical situation, the children used their rational knowledge and not their phenomenalistic perception. When retested in a theoretical situation, the children retained their rational knowledge and gave up their phenomenalistic perception of the display. It appears as if Piaget was right. The results strongly supported Model 1. Rational understanding replaced phenomenalistic perception in both domains, in children's verbal judgments and in their practical actions. However, Piaget's phenomena are known for their fragility. But what if a stronger phenomenalistic illusion is used? To examine this, in experiment 2, Miller-Lyer illusion was used.
Children of the same age groups were shown a board with two equal rulers stuck to the background drawings. One had its angles directed upwards and the other one downwards. The illusion makes us see the ruler with the dove-tailed endings look longer.
The children were asked, are both rulers of the same length, or is one longer and the other one shorter? Which one is longer? The children were then asked to remove the rulers from the background, place them side by side, and see that they were of equal lengths. By this, phenomenalistic perception of the rulers, one is longer than the other, was contrasted with the rational understanding. Rulers are of equal lengths. Testing in a practical situation was done as follows. The rulers were returned on the background as the children watched. The experimenter then suggested that if the child could reach a pretty stamp with his or her hands without getting off the chair, then he or she could keep the stamp as a reward. The stamp was placed on the floor, far enough away so that even with the child's hand outstretched, there was still a gap roughly equal to the length of the ruler. After a few unsuccessful attempts, the child was suggested to use one of the rulers as a tool. We expected that if the children used their phenomenalistic perception of the ruler's lengths, then the children would pick up the ruler that looks longer more often than at a chance level. If, however, they used their rational knowledge, then they would pick both rulers at a chance level.
As we can see on this graph, 100% of children answered that the dove-tailed ruler was longer, and over 80% used this ruler in order to reach the postage stamp. When the rulers were reinstalled back to the backgrounds and the children were asked again whether the rulers were of equal lengths, over 80% of children correctly said that the rulers were the same length.
To conclude, we can say that in a practical action, children relied on their phenomenalistic perception of the ruler's lengths and not on their rational view. However, when retested in a theoretical situation, the children retained the rational view and rejected the phenomenalistic perception. The results conform to Model 3. Phenomenalistic perception coexists with rational understanding in children's minds. Children displayed the dissociation between words and actions. They relied on phenomenalistic perception when solving the practical problem, whereas in their verbal judgments, they relied on their rational understanding. In experiment 3, perception and rational understanding of causal relations was studied. 3 small transparent beakers were placed before the child. All of the beakers contained something that looked like colorless liquid. In reality, one of the beakers contained a base solution, natri OH, the second contained an acid solution, and the third contained a phenolphthalein, an acid-base indicator, solution. Alongside the beakers, there were 2 small cut cylinders, red and white. Questions and manipulations were as follows. The child was asked, what color is the liquid in cylinders? What color would the liquid be if I pour the liquid from this beaker into this one, phenolphthalein into base? A red cylinder is then placed around the beaker with the base and the phenolphthalein is poured into it. The cylinder is then removed and the child sees that the clear liquid turned bright pink. More questions are asked. What color would the water be if I pour this clear liquid, the acid solution, into this pink liquid? The experimenter then placed the white cylinder over the beaker with the pink liquid and poured the acid solution into it. On removing the cylinder, the child can see that the liquid became colorless. Key questions were then asked. Why did the liquid become pink? Why did it become clear again? The purpose of these questions was to see if the demonstration created in children phenomenalistic view of causal relations, that the cylinders make the liquid change color. Children were then explained how the liquid really changed color.
Children were first shown this display and told that the three pictures on top of it represented the beakers and what they contained. One beaker contained little balls with hoops in their little hands. Another contained little balls with hoops in their hands. And the third contained balls with hammers in their hands. When I poured the liquid with the hoops into the liquid with the hoops, the balls got caught each other and could not separate. They became angry and red, and so the liquid reddened. When I then poured the liquid with the hammers into the red liquid, the little balls with the hammers broke the hooks and hoops free, and the balls became happy and white again. That is why the red liquid became clear again.
Testing in a practical situation was done as follows. Children were then asked to try it for themselves and make the liquid red and clear again. If they succeeded, they were promised a nice postage stamp as a reward. Expectations were as follows. If in the practical situation children used their phenomenalistic perception of the causal relations, they would use cylinders to produce the effects, despite the fact that cylinders were not employed in the rational explanation. If, however, they used rational understanding, they would not use the cylinders.
As we can see on this graph, about 100% of children answered that the cylinders had caused the color change, and about 90% used the cylinders to achieve the effect in the practical situation. When, after they had been explained the rational mechanism of the color change, the children were asked again whether the cylinders were the cause of the color change, up to 80% of 4- and 5-year-olds confirmed that, but most 6-year-olds denied that cylinders had anything to do with the color change.
We can therefore conclude as follows. Despite the fact that the cylinders were not mentioned in the explanation, not only children used the cylinders in their practical actions, but also, when asked again, most 4- and 5-year-olds insisted that cylinders in fact had been the cause of the effect. This means that phenomenalistic perception of the causal effect was extremely powerful. Not only it overpowered the rational view in children's practical actions, but it also replaced rational understanding in children's judgments. All this strongly supports Model 3, conservation, coexistence. Overall, the results of 3 experiments supported 2 out of the 3 models of the relationships between phenomenalistic perception and rational understanding. When the phenomenalistic perception is psychologically unstable, experiment 1, it is being replaced by the rational understanding, both in children's judgments and in their practical actions, Model 1. When the phenomenalistic perception is psychologically powerful, experiments 2 and 3, it remains in the children's minds along with rational understanding, Model 3. And it can even supersede rational understanding when it goes about solving a practical task, as in experiment 2, and replace rational understanding in children's judgments, as in experiment 3.